Hi, and welcome to AP Chemistry. This is our third session, our third and last session today. And today, the team that I have with me. So I am Dr. H, instructor for the Princeton Review. My moderator is Marcy, and Marcy will be monitoring the feed that you put in, and she will be feeding me the questions, the comments that you have. And of course, the person who makes all of this happen is Brian, our tech magician. And I know they're doing multiple sessions today, which is awesome. So I know they're really hustling here. Now, before I start with anything else, what I wanted to do is to correct one of the things that that was in yesterday's session. So yesterday, for one of the questions that we had the rate equals constant concentration of NH4 plus concentration of NO2 minus squared. And the question was, what are the units for K? Okay, the rate is always moles per second. Now, I did put these as moles per second, which is incorrect. These are concentrations. And so this should be a mole, and this should be moles squared. Now, what should this K be such that we get moles per second? So I need a per second here, okay? And I have moles cubed here, and I only have a mole here. So I need a mole to the -2 here. Let me just move this over. I need a mole m -2 seconds -1. So I think what I did yesterday is I put the wrong units here is what I did. So I did want to correct that today. So so you actually do have the right information. So let's get started on today's session. Of course, on the agenda today is, of course, the 2021 AP testing. It hasn't changed. Preparing for the AP Chem and how we at Princeton Review can help you. So I've shown you the schedule earlier, and as you see, we are not that far off from the first test. It is a paper and pencil test, and it will be in your school. It's going to be offered in your school only. May 25th will be the second administration, and that is also a paper only, and that will also be in your school only. The June 10th administration will be a digital one, and depending on your school, depending on what your school says, you may be able to take it at school or at home, depending on how they are set up. To ensure that all the times everyone takes it at the same time, they have set the time at 12 p.m. Eastern Daylight. So that might be different for some of you. The paper and pencil test here is 8 a.m. local. Okay, these are the units that are covered. And as you see, all of them are about the same, except for IMF, intermolecular forces, acids and bases, and it turns out that thermodynamics gets a double hit. Okay, so it gets covered twice. I didn't put down how the breakdown is because we've been talking about that. So how do you actually prep for AP Chem? So what I have here today is I do have a question that we can go through. And as you see, the long question, which if you're taking the paper and pencil are the first two questions, and they are long, you will have one such question if you are taking it online. This is a galvanic cell that is set up. They will give you a diagram and maybe a little bit of information. So here they're giving you that. And you will notice that there are several parts to this question. The way these parts are laid out is that they are meant to build on one another. The later parts build on the earlier parts. However, sometimes looking at a question like this, it's easier to answer some of the later parts before the earlier parts. Towards the end, what they typically do is they may ask you a theoretical question. Here they don't. but sometimes they do ask you a theoretical question. If they do ask you a theoretical or a general question, it may be that you can answer that question just based on your theoretical knowledge that you have. For long questions like this, you may want to. Some people like doing basically writing their formulas and things like that. Here is something that is related to a galvanic cell. And so what I may do is, as far as my formulas go, I may want to write down that my coulombs is current times time. I may want to write down that my moles of electrons is equal to my charge over Faraday's constant. Okay, or whatever other equations that you may have. Yes, you can. You don't have to do that. Some people, it's better. It reduces their stress if they just write it down like that. So let's take a look at what they are telling us here. So the first couple of problems are supposed to be easier. The last one is supposed to be theoretical. The ones sandwiched in here tend to be medium hard. So the first question says, write out the balanced net ionic reaction that will occur in this particular case. They tell me it's a galvanic cell. So galvanic means it is a spontaneous cell. Now, here is the interpretation. This is a spontaneous cell, which means that my E is greater than 0. Okay, so as I'm writing them down, there we go. So they show me the table here. I know I want an E that is greater than 0. Remember, one will be an oxidation, one will be a reduction. So I'll have to flip one of these reactions around. And the one that I will need to flip will be the second one. So my net reaction will be Ag plus an electron to give me Ag solid, and Ag solid. And my E is going to be plus 0.80. My second reaction, I will flip the second one around. So I will have tin solid, which is going to give me tin plus 2 electrons. And this will be now plus 0.14. And while this is the case, what I have to do is, if I'm going to add them up, then I will need to make sure that my electrons cancel. So the way I make sure that my electrons cancel is I will have to multiply this reaction by 2. And you noticed that I am multiplying only this and not the E0. And you may say, why aren't you multiplying the E0? You may have learned it's an intrinsic property. But the way you look at it is that if you look at the E0, the units for E0 are actually, they are the units as voltage. So a volt is actually joules per coulomb. Or another way of looking at it is energy per electron. So while I may have twice as many reactions going on, my energy per electron will stay the same. And therefore, I only need to multiply this by 2, not this. So my final reaction is going to be 2 Ag plus Sn to give me 2 Ag plus Sn plus 2. Okay, so that is my reaction for this cell. If they want me to calculate the E for the cell, the E for the cell is the addition of these two, which is positive 0.94. I could put down just 0.94. Typically, I like to put a positive sign because that actually lets me know that that I have thought about the sign as well. So let's take a look at part B. Part B, it says calculate E0 for the cell. So we know E0 equals 0.80 minus a negative 0.14, which is equal to a positive 0.94. And typically you want to put the unit down as well, volts. Now, if you're looking at delta G0 equals negative NFE. That's one of those equations I should have written down. Well, maybe would have written down. Sometimes you need it, sometimes you don't. So in this case, it is negative. The N is number of electrons. So in this case, it is 2. Faraday's constant, 96500. It's just a constant. And the E of the cell, 0.94, which then is going to give me a negative number, which is a good thing. And it's going to give me negative 180,000. This is joules per mole, which is also equal to negative 180 kilojoules per mole. Okay, either answer is acceptable. Typically, we report these in kilojoules per mole, but there is part B. Okay, so let's take a look at part C. It says if the solution of each half cell were replaced with a 2 molar solution, right now they have 1 molar solution of AgNO3 and tin nitrate, how would that affect the cell potential? Justify your answer. Okay, so what we need to do is as we look at the reaction, remember that Q is actually equal to S. If we're looking at, well, okay, maybe I should write the reaction down. That might be what we have to do. So if we're looking at the reaction, we know the reaction is 2Ag plus, and this is aqueous, plus Sn, which is a solid, to give us Sn plus 2, which is aqueous, plus 2Ag, which is a solid. Now, when I write Q, it is products over reactants. Okay, and in this case, my products is Sn plus 2 divided by Ag plus squared. Okay, now initially, what I had was so initially I had 1 over 1 squared, which is just 1. And the new Q is equal to 2 over 2 squared, which is a half. So the new Q is less than the old Q. Okay, so that means I have more. Well, okay, so Q now wants to be closer to K, but essentially what I've done here with the Ag plus 2, because that's more, so it's become smaller, which means it will want to shift towards products. And if it want to shift towards products because it's become smaller, it wants to be bigger now, that means E will increase. Okay, so that is what's going to happen as far as my cell potential. Okay, so we can say cell potential will want to go, will want to increase. Okay, so what is the purpose of the salt bridge? And then suggest a formula that would be a good choice in fitting the salt bridge and justify your answer. Now, in this case, if you don't want to justify the salt bridge right away, or may want to think about it some more, answer number two first. It doesn't matter. So the purpose of the salt bridge is really to allow the flow of ions, okay, to each half cell. And the reason why is to maintain electrical neutrality. Okay, so that's really the reason, the electrical neutrality of each half cell. Now, if I have to suggest a formula for something that goes in the salt bridge, remember what the salt bridge has to do is it has to transfer ions, but that's about it. So it needs to have, these ions can't take part in a reaction. They can't be interfering with it. So they need to be spectator ions. And when I say spectator ions, I mean like these where they watch the basketball game, but they actually don't play in the basketball game. Okay. So what I'll have to do is notice that I have silver here, and we know that silver, or at least compounds of silver, are insoluble. So I'll need to figure out something that actually is soluble with both silver and tin. The nitrates I don't have to worry about because nitrate salts are soluble. So basically, what would not make the silver precipitate? Well, they're using nitrates here, so it's a good bet to use a nitrate salt. Typically, my go-to salt is potassium nitrate. That's what is used. Okay, and because it does not cause precipitate. Or if you don't want to use potassium, you could use a sodium nitrate. Both of these are generally very safe salts to use in a salt bridge where you want them to just transfer charge and not cause precipitate of anything else. That's why they actually probably gave you the silver. Sometimes they'll give you a barium or a sulfate in there, and you got to watch it because those may actually cause a precipitate, and that's not what you want. You're looking at other effects that um, you know you may not want in your reaction. Okay, so I know what you're thinking. This is electrochem. Hopefully you learned something new and shocking. No, I'm kidding. Uh, so the beaker is disconnected from the cell. Tin electrode is then connected to an outside source of current. So now we have an outside source of current. And over the course of 10 minutes, we have 1.6 grams of tin plated onto the electrode. What is the amperage of the current source? Okay. So here, when we have time-based calculations, these time-based calculations tend to be, at least as far as electrochem goes, they tend to be among the most feared of um, of these types of questions. Okay, but because you have one equation, you gotta know how to use it, and that's about it. Instead of looking at one equation, let's break this down into smaller equations and treat it as uh, treat it as stoichiometric. So what is really happening here? What is really happening here is that we have Sn plus 2, which is gaining 2 electrons, and it is forming tin. That's what it's doing. Okay. Now, whenever I have something like this, and they give me how many grams of tin are formed, if I know how many moles of tin are formed, I can calculate how many moles of electrons were used. So let me start with that. Moles of tin is basically 1.65 divided by the molecular weight of tin, 118.7, which gives me approximately 0.014 moles of tin. Okay, now looking at the stoichiometric ratio, if I know the moles of tin, I know how many moles of electrons I have. And because this is in a 1:2 ratio, I know moles of electrons is equal to twice the 0.014, which is 0.028 moles of electrons. Now I know charge is equal to the current times the time. So I can rearrange this equation. Oh, wait, hold on. Getting ahead of myself here. Uh, Moles of electrons to charge, what I have to do is moles of electrons equals charge over Faraday's constant, which means my charge is equal to 0.028 times Faraday's constant, 96500, which gives me 2683 coulombs. Okay, so now I know the charge is equal to the current times time, which means the current is equal to the charge over time. Okay, and so the current is actually 2683 over the time, and the time that they give me here is 10 minutes. I need it in seconds, so I'm going to multiply it by 60, which gives me 4.47 amps. So current equals 4.47 amps. Now, what did I do here? I used this stoichiometric ratio to figure out how many moles of electrons I have. I use Faraday's constant to convert from moles of electrons to charge, coulombs, if you will. Okay, and then I can use this equation, the charge equals the current times time, to look at the current. Now I can run this backwards as well. Sometimes it will tell me the current and the time, so I need to find the number of coulombs, and then from the number of coulombs I can use Faraday to find moles of electrons, and from moles of electrons I can then figure out whatever else I need using this. So once you go through it, and in the 3 different steps, what happens is now it doesn't matter how they actually uh, twist and turn the problem, you can always get it right. Okay, so now hopefully, now that you know that, you can actually approach this problem with no fear here. So we're going to get rid of that. We're going to get rid of that scared-looking person and put a no fear clip art here, because now you can break the problem down rather than using one big formula and work through it stoichiometrically. Okay. So let's take a look at the next long problem that we have. Here's a next long problem. I don't have the questions on this slide, but I wanted to show you the picture that it has. It has a can on on a gauze that's being lit by a lighter, and it says it's an aluminum can. They tell me that a pressurized liquid butane is set up underneath the can. It contains 100 milliliters of water. This one does. And butane is ignited. The temperature inside the water goes from 25 to 82. The total mass of the butane, they tell me that. So typically I like to highlight some of the salient features that they give me. These are the constants that they give me, and this is the density of water that they give me. So this looks like a heat transfer problem, and the equation I will need is Q equals mc delta T. They give me density as well, so I know density equals mass over volume. So these are some of the equations that it looks like I will need. Um, this looks like a chem equation. This looks more like a physics equation, so I'm not sure why I would write that down. But they give me density here, so maybe I will need that. And they tell me that there is 100 milliliters of water anyway. The can contains 100 milliliters of water to start with. Okay, let's take a look at the questions. So here's a question. I'm sorry, here's the background information. Here are the questions that we have. Write a balanced equation. How much heat did the water gain? Things like that. So it's like, okay, this looks like there is combustion going on here, and it looks like there is heat transfer going on here. So it makes sense to use the equations that I have. So let's take a look at A. The first one says write a balanced equation. So if I'm writing a balanced equation, I know they start me off with butane, C4H10. And because this is a combustion reaction, I know it's going to combine with oxygen. And what I will get as my result is carbon dioxide plus water vapor. So typically what I like to do in this case is notice that the H's only show up in one spot. Okay, so what I will do is I will put a 1 here and a 5 here. And you're wondering why I'm going to put a 1 here, because I don't want to change this. I know I fixed it to this one already. So I'm going to put a 1 here to tell me that I have fixed it. And I know I have 4 carbons here, so I need to have 4 carbons here as well. On the left, 4 carbons on the left, and therefore 4 carbons on the right. Now I got to add up all the oxygens. So here I have 8 oxygens and 5 oxygens. That is 13 oxygens. So this is now 13 over 2 because it's diatomic. Typically, I don't like writing a reaction like this, so I will multiply everything by 2 to get 2C4H10 plus 13O2 to give me 8 CO2 plus 10 H2O. Okay, so this is actually the proper balanced equation that that they need, that they're looking for. How much heat did the water gain? Here I'm going to use the equation for heat transfer that we had. Q equals mc delta T. So I need to know the mass of water. Well, the mass of water in this case is, remember we have 1 gram per milliliter. So because we have 100 grams, I know, excuse me, because we have 100 milliliters, so the mass is equal to 100. They give me C, the specific heat, that's 4.18, and delta T, which is equal to 82.3 minus 25, which in this case is 57.3. So Q is equal to 100. Now, one of the things that I want to do is I want to make sure that the units are right here. This is 100 grams. So is my C in grams? Oh, yes, it is. So that's good. Okay. Sometimes they will give you this C in degrees Celsius or degrees Kelvin. It doesn't matter if it's degrees Celsius or degrees Kelvin. That really doesn't matter because you're looking at delta T. So delta T Celsius is the same as delta T Kelvin. And then my delta T is 57.3. Okay. And when I multiply all of these out, I should get 24,000 joules, which is actually 24 kilojoules. So that's going to be my answer for part B. How much heat did it gain? Number two, they actually ask for what is the experimentally determined heat of combustion of butane? The answer should be in kilojoules per mole. Okay, so this is number one. Number two, what I have is I have 0.51 grams of butane, C4H10. This is going to translate to, now I need to find the number of moles of butane. So this will be 0.51 grams over 58 grams per mole, which is equal to 0.0088 moles. Okay, this is moles of butane. So I know 0.0088 moles gives me 24 kilojoules. So 1 mole will give me 1 mole. 1 mole is going to give me 24 kilojoules divided by 0.0088, which is equal to 2,700 kilojoules per mole. Okay, now I know this is an exothermic reaction. So that means now my heat of combustion is equal to negative 2,700 kilojoules per mole. Okay, it's a good idea to actually go ahead and write your final answer out, even though the number is right there, or circle your final answer such that the examiner knows what you are, what you intend to submit as your final answer. Oops, went too far, didn't I? Okay, there we go. Given butane's density of 0.573 grams per milliliter at 25, how much heat would be emitted if 0.5 milliliters were combusted at that temperature? So what I have to do here is I need to know what is the mass of butane that we have. So I know the density is, well, they give me the density and they give me the volume. So I know mass is density times volume, which is equal to 0.573 times the volume, which is 5, which gives me a mass of 2.87 grams. Okay, so basically, once I know the mass, I need to find moles of butane, which is 2.87 grams over 58, which is equal to 0.049 moles. Okay, so now I know what the uh, what the heat out would be because I just calculated that in the previous part. Okay, so heat would be 0.049 times my number, which is 2700, and this is of course kilojoules per mole. Which is equal to 130 kilojoules of heat. And in this case, it is emitted. Okay, typically I like to put down what direction the heat is flowing as well, so that we can capture that too. Okay, so here is where they give me a question that is theoretical. It tells me that the overall combustion of butane is an exothermic reaction. Explain why this is in terms of bond energies. So when I'm looking at this in terms of bond energies, essentially what happens is that more energy is released. And maybe I can type this. More energy is released when products are formed than is required to break the bonds in the reactants. Okay, so that would be my my explanation in terms of bond energies. They're not looking for anything more than that, so I can just leave it like that and be done. The last part they're telling me is that one major source of error in the experiment comes from the heat absorbed by the air. Why then might it not be, so here they're telling me which way to go, not a good idea to perform this experiment inside a sealed container. Now, remember that what's happening here. So let me write down the equation, the reaction equation one more time. We have 2C4H10 H yeah, plus 13O2 to give us 8CO2 plus 10 H2O. Okay, so what we have is, remember our assumption is that all of the butane combines and we have excess oxygen. So in a sealed container, so there are two things I can say. In a sealed container, may not have enough oxygen for all the butane to be consumed. So that would be one thing, they may just not be enough oxygen. So if it's not the so now I gotta justify it a little bit more. So uh, if there isn't enough oxygen, what does that mean? Okay, so that means that butane will not be the limiting agent as we had assumed earlier. Okay, so our calculations then will be off. Okay. So this will throw off our calculations. Okay, so that's one of the things that can happen because not all the butane will burn. The other line of reasoning that you can take, it might be a little bit harder, is that what you will notice here is you will notice that I have 15 moles of gas on the left side and I have 18 moles of gas on the right side. So it may turn out that the pressure of the sealed container is going to increase, and it may exceed the strength of the container and cause an explosion. Okay, because there are more moles of gas on the reactant side than on the product side. So an alternate explanation may well be uh, that as there are more moles of gas of products than there are of reactants, the, the pressure of the container will increase and may exceed the strength of the container. This would cause the container to explode. Okay, so there would be your another alternate explanation if you don't want to reference um, the limiting agent. So both of these would actually work. Okay, so how do you approach the long answer section? So the way you would approach a long answer section is you want to scan the questions, okay, and you want to rank the questions based on topic familiarity, how familiar you are. The more familiar you are with a topic, the greater will be the probability that you will actually get the questions right. You'll be able to do them well. You'll be able to remember the formulas. You want to start with the most familiar topic, especially when it comes down to the theoretical questions. That's when your familiarity with a topic actually does pay off. Okay, you want to complete all parts of the question before moving on. So this is this idea that if I want to do a question, I want to do a question completely and be done with it. I don't want to come back. Because what happens is if you come back to a question, you are you'll pick up what, maybe half a point, but you're giving up that time when you could be picking up a whole point on the new question. So that's why I like to think of it as, when you're done with the question, you're done and you're going to move on. It also keeps you sharper if you know you have only one and done. If you're going to limit yourself to a one and done kind of deal. So keep in mind that the later parts build on earlier parts. You saw me using uh, basically answers from an earlier part on the later parts, and also the later parts ask more general or theoretical questions. And if that's the case, then those are the ones you do them. So the default is to do the parts in order, but don't be afraid to do the larger parts if they are easier. Okay. So yesterday I did say I would talk about strategies for the digital test. Remember, the digital test doesn't have as much choices for what you need to do because you can only see a single question at a time. If these are the free response questions, you can move around within a question, but once you answer the last part of the question, it moves to the next question and you can't go back. So bear that in mind when doing it. So for the multiple choice, read the question, okay? And the first thing you want to do is not dive right into answering the question. I hope you saw that the first time that we went through this. It's a good idea, whether you're doing multiple choice on the digital or the non-digital, to actually look at what answers you can eliminate. It gives your brain that little extra time that it needs to process the information subconsciously. So now you can make better decisions when you are actually solving the problem. Eliminating an answer choice doesn't take that long, and it's basically good practice to get into for multiple choice. Okay, if it's an easy question, finish your work. If it needs a few calculations, okay, fine, do the calculation and be done with it. If it is not an easy question, now you have a choice of finishing, which will take time, or if you've eliminated answer choices, guess from the remaining answer choices and move on, because this question has now could potentially be a time suck. Okay, it's going to take a lot of time away from you, and if it becomes a time suck, you are better off walking away and using your time someplace else. So that's one of the things you got to watch out for. It deserves a special clip art of a time suck right there. You're going to starve yourself for time on the questions that you can answer and make silly errors. On the short answer, what I would recommend is read all parts of the question. They're only like 2 or 3 parts, so read all parts of the question. Okay, so the default is to do the questions, to do the parts in order. While that is the default, if there is a good reason for you to do a later part because it's easier, because this part that you're on is harder, you don't know how to start, then don't be afraid to do that. Okay, and then before moving to the next part, before you finish this part of the question, make sure that you have answered the question. It is unfortunate when you don't answer the question or you answer a different question than the one that they asked. The grader can't give you the points. So make sure you have answered the question. It's good practice to just go back and review to make sure that you have actually answered the question that they're asking. Just reread the question one more time. Okay, on the long answer, I would say scan all parts of the question. You don't have to read them, you can scan them. Just so that you know what's coming. Write the relevant formulas, and I put that down as optional because some people like to do it, others don't like to do it. However you may be, whichever side you may fall on, that's okay. Um, People have success rates with both options, so I'll just put that down as optional. And here again, the default is to do the parts in order. If there is a reason to do a later part, then do it later. So the reasons are the part I'm on is harder, or I don't know how to start, or a later part is easier, then go ahead, and those are good reasons to then move away from the default. Okay, the last parts tend to be theoretical. Don't skip those. If they are theoretical, you can answer something at least from what you know. And if you answer something, at least answer that. At least go for the partial credit, uh, unless you're completely lost. And I don't think you'd be completely lost. Otherwise, you won't be able to. You would probably not even be in your AP Chem course to begin with. I mean, you went through the course, so you would be able to answer at least some pieces of it. Okay, how do you prep for the test? Take the test, take practice tests. You may know all the content, but if you have not tried to do the test, you are missing out on mechanics of the test. That is just as important as what you have in your head. So take the practice test, know the format and the instructions ahead of time, understand the content that's being tested, practice under test conditions. This is your practice, right? This is your prep work. Part of the prep work is not just the content, but actually how to perform under test conditions and adjust your strategy um, accordingly, depending on how your practice tests go. No matter what, plan to celebrate after the test. This way, no matter how you do on the test, you have something to look forward to. While people while people practice the content uh, or study the content, it is just as important to study the practice. Do something to help you study the, take a practice test or what have you. How can we help? We can help through, uh, what is our strength? We help people understand how to take standardized test, and the way we can help is through our live streams, through scheduled tutoring programs, our on-demand tutoring, and our cram courses. The cram courses are designed to give you the content that you need for these tests. That's what they're designed to do. They're saying, here is the content that you need. That's why they're called cram courses. Okay, and in addition to that, what we have is we have our AP books. At a minimum, take one practice test. Okay, I will take any questions that you may have, and I will actually give you one clip art. It's my favorite clip art because I hope this is what you do on the day of the test. I call her the Karate Girl, and there she is on the top right, because this is what I hope you do on the test. I hope you crush the test. If there are no questions, the very, very best of luck to you. And if there are, certainly I will be here to answer them. And I know Marcy is on standby to pick up any questions or comments that you've had. That's a good question. The question is, how do we find out if if the answers that we got are wrong or right? Okay, so the way you find out whether the answers that you got are wrong or right, if you are using one of our premium books, is that they actually do give you explanations at the back. If you are taking the real test, I assume the question was based on the real test, you actually are not told that. Um, uh, the reason why, how you know, because if you want to find out after the fact of the test, it's a little late then. Your grade is already in. The reason for going through the right or wrong answers is actually during the practice to prep you for the real test. Okay, so while I don't think I answered your question directly. I hope I gave you enough to go on. I do know that our prep books at the end of every test, they do give you explanations. It's not the real thing. I understand that, but really, what you want to do is prep enough with the practice material so that on the real thing you pretty much know what you're going to get. Awesome. Good luck to all of you. There are no additional questions, so the very, very best of luck to you. Thank you, Marcia and Brian. And I know you guys have to go to the next session too.